Yeah, she was here. I don't know where she's at now, but.
Oh, okay. You like it?
I can call her. I said she's gone.
It's really good though. My best friends with the owner.
Yeah, I struggled with
That was
Sorry, I don't stand. That's what it was.
We have a whole group of people already, so that's so you can ask for help if it's tougher, yeah? No, I kept them. I put them in my third tall cabinet. Or they're my.
I literally thanks, Reagan. Yeah.
No, it's irrational. Well, Monday at least, if you wanted to move to one of these.
Oh, that's actually a really good idea. So move over there. Let's work together. Thank you.
Math is easier with other people.
True. Hey, is this test like commonly harder for others, like other students? Okay.
Are you laughing? I feel like every day we've done the same thing and repeated, and then started one more thing. Like we repeat every day and add one more thing.
One more.
One more. Every day. Every day. Am I sixth grade or fifth?
Oh, sure. Wait.
No, it's my midterm.
Let's start with our Thomas Reed. Thomas Reed. You watch that thing?
Oh, yeah.
Watch the whole thing through. Just come on.
I mean, that's
Yeah.
true.
You should make yourself.
Is
Watch the whole thing
You
through.
remember when I said there was the one thing out of the
it's just where the line is. We were at a college the breaks.
No.
No, there's one in my phone.
Snow White, I don't know if we should be doing that.
Oh, hi, Jenna. I like your sweater. You should go to class. Okay. Thank you.
It's, well, you can set the x value into the equation. You like take whatever your whole number is. And you can see
Just think of that in what is more likely. Landon showing up to class where Jake's making the models in U Engine today. It's one of those two is more likely.
Rational means fraction. Rational and fraction mean the same thing.
I just like
So not write it down 1,000 million times.
Well, if you don't
Because vocab is where we're struggling this year.
Oh, yeah.
I've said that about 1,000,000 times.
no, you don't have a line.
Wait, how many tickets excuse something like?
What if we spend a whole day and just make them write rational equals fraction 1,000 times?
I mean, if,
Oh.
if, like, you can have homework at once. Right? You know what, you make that an extra credit assignment and I will come in with a paper that says rational. I'm just saying, if you make it an extra credit assignment, I will actually do it. It's the easiest assignment.
Or a grade on your test, knowing what rational means, like that's what we go.
What about a regular credit assignment, like a 4.3 homework, a regular credit?
And you just have to write it, you have to just have us write it. I'll do it.
I'm just saying, just do your homework, like regular homework.
Let's
I just-
move on.
I have them go quickly, but I just.
Wait,
very good.
and the X intercepts.
How do we find the x-intercepts of a rational function?
So why would you?
Set the numerator equal to 0.
Or another way of saying set the numerator equal to 0. Because when you put 0 as y, you're going to multiply the denominator and it becomes 0. So you could just set the numerator equal to 0. How do we find? That's x-intercepts. How do we find y-intercepts? The opposite, set x equal to 0. Or you could say
Plug
put
in 0 for
0
X.
for all x's. What form should your intercepts be in? Notation.
Parentheses.
Parentheses. Okay, this is gonna look like x value comma 0, 0 comma y value. Okay, what's a rational function?
Fraction.
It's a fraction. How does it look like as a function?
X plus 1 over X plus 2.
Okay, when will we not have any x-intercepts in a rational function?
There's no X's in the numerator.
No x in numerator. When will we have a hole in the graph?
When the excluded value answers the removable discontinuity.
Yes, when the excluded value can simplify, reduce to 1.
All right. My bad.
How do you find the y value? Somebody other than Drake. I know you know it, and it's awesome.
When it cancels. Actually, wait.
How do we find the y value? So we have that the whole is when the excluded value can simplify. Or we also said a removable. That would be here, non-removable.
Wait, what did you ask?
Okay, we're here. How will you find the y value of your pole? How do you find the coordinate of your pole? Yes.
You use the excluded value. and plug it into
Yes, so you use the excluded value, that reduced, and plug it into
Oh.
the simplified equation. Good, and that will give you the x value and the y value. That is an L, not plus. Any questions on that?
No.
So then we said the vertical asymptote was the non-removable discontinuity. Or does someone else want to explain that? Raise your hand. Yes.
Doesn't cancel with
And what is the it?
the exchange value.
The excluded value that doesn't reduce to 1. And it's written like what's what you remember? Preston, do you know? What does a vertical asymptote look like? Like, what is the equation?
It's actually equals something.
Yes, x equals excluded value. Wait, how do we know where the horizontal asymptotes are? Jonah.
It's like to do with the behavior. So if there's a higher degree of X on the bottom than the top, then it would equal 0. And if there's a higher degree of X on the top and the bottom, then there wouldn't be a horizontal asymptote. And at the same degree, then you would use the coefficients on the top and bottom.
Yes, exactly. If the denominator is bigger than the numerator, then what was the vertical or the horizontal asymptote?
It is. And if the numerator is bigger, then there's none.
And if they're the same,
Then it's the coefficient.
Huh?
What?
so the coefficients divided. Okay,
We talking about.
so let's look at
Wait.
sorry.
Oh, sorry. Big videos.
Okay.
Are we going to do this little example problem?
What?
The little example problem?
Yeah, I'll do that. I'll rewrite it. Y equals 3x squared minus 9x over x squared minus x. Let me just, am I good to choose a page?
Yeah.
Oh, we're not doing the bottom.
No, we are. I just want to look at what they're.
Oh.
I want you guys to work together on this. If you guys want to do it together, do you want to do it as table groups or together?
Together.
Okay, let's do that.
What are we doing?
This problem. Okay, what are the x-intercepts?
We can't see. Well, shouldn't we take out the GCF first?
Yes. No, they should be good. I was not confessing. Huh?
I said, I'm okay, I was not complaining. It's actually nice when I don't sit next to anyone because then I actually get marked up.
Okay. Now the word is first, so I'm gonna have to move to the desk.
Thomas Reed doesn't look like this.
They made up a whole life personality about Thomas Reed.
Wait, can the x's cancel and then you're just left with 3 on the top, or does that not work because of the coefficient?
It does work.
Okay.
Did you hear her? Say that louder.
I just asked if the x's could cancel or if they can't because of the coefficient, the 3. But I think it's because they're like GCF, so the x's can cancel. Then you're just left with the 3 and then the parentheses x subtracted by 3 over the x minus 1.
So what she said is you can cancel, reduce to 1, these x's. But we have to consider them though, right? Still have to consider that x on the bottom. At what point?
The
Excluded.
Excluded values, perfect. Okay, so the x-intercept, we use what to find the x-intercept?
the conjugate,
Not the conjugate.
whatever it is,
Then setting numerator to 0.
Yes, set the numerator to 0. 0 equals 3, x minus 3. Therefore, x equals
3.
3. So the x-intercept is 3 comma 0.
Yeah.
Okay.
Wait, but what happens with the 3 on the outside? Does that
It
just
says 3 equals 0. Can you do anything to 3 to change it? Because there's no x by it, so the 3 just kind of goes away. You could say like you divide by 3 first.
Oh, and then it just like
0 equals x.
basically cancels. Okay, yeah, that makes sense.
So whatever.
Okay, this table. How do I find the line intercepts?
For what?
This problem.
So the x is
Set the x's to 0. 3, do you have a question? Okay. I have a question.
Let's hear it.
What are, okay, so, let's hear.
Definitely wasn't Steve.
Okay, so we found out that was y-intercept, but I'm going to do a question mark there. Why do you think I'm doing a question mark there?
Because it's a question. You're not sure
So,
about it.
what are our points of discontinuity?
0 and 1.
0 and 1. So can I plug in the 0 into this equation?
Away. Yes. No. No.
Can I
One
have a
question.
0 or- Yes.
She just asked.
How do you know that the points of discontinuity are 0 and 1?
They are the excluded values.
So because that x is right there,
This is
right
x,
there.
and x minus
Is that x on the outside means that it's 0 and then the 1
Yep. You always, when you're looking for excluded values, you always go back to the original equation, not the simplified. Original. Good? So since our excluded value is 0, that means this can't be plugged in.
You got a wire.
There's no y-intercept. What is it doing, do you think? We're gonna just kind of guess, and then we'll see. What do you think it's doing at that y-intercept? Okay, is that what you're gonna say?
Well, I was gonna say it's not a.
Yeah, so it's still going towards that y line, right? It's still going towards the y-axis, but it hops over the line because there's a hole. Okay, so we're gonna see that. That's the point.
There's a hot blender.
Okay, so we're gonna what our y equals 3x minus 3 over x. Original was x here. Okay. What is a horizontal axis?
Whoa.
Sorry. Oh, you can read it.
Okay, I guess horizontal is y plus 3.
Where did you get 3?
It's the coefficient I got.
Yes. Are these degrees the same?
Yes.
Yes. So what are our coefficients? Coefficients. 3 and 1. So this is y equals 3. And then we kind of talked about this. Are there any holes?
No.
Yeah, because they cancel.
Yes.
I just have a question. So like,
Yes.
let's say the
Yes.
coefficient wasn't 1 and it was like 2, would it be like, would the horizontal asymptote be like 3 over 2?
Yes.
Okay.
Steven, what did you say?
That's right, Stephen.
Let's hear it.
Yeah. All that was funny.
Alright, let's go back here. Focus. Are there any holes? We talked about this. Where is the hole? At 0. And then, ooh, what did you say?
0.9.
0.9. Why did you figure that out?
So you wrote it on the last page.
We wrote it on the last page because we plugged in the excluded value that reduced into our simplified equation
What's that?
and got the 9.
What?
What's that?
22.
Oh, I thought you were like trying to make it 9. I was like, nice 9.
We had 2 excluded values, 0 and 1.
So did the 1 help make it a 9?
Where's the nine? Yeah, can you explain how? Yeah, you explain that.
I'm just.
Yeah. Okay, we're gonna
Last
go back.
page.
Let's rewind. Hold on. I'm waiting for this moment. Are you ready? Let's rewind.
Oh my God. That's so funny. That was
Hashtag worth it. Yeah. Hashtag worth it.
All right, back here.
We go back to what it was.
Let's go back to page 9. How do we find, let's read this one right here. Okay, wait, you guys asked me why, so let's listen.
I'm listening. I'm listening.
That was my bad. I was chatting. I know. Sorry.
When will we have a hole in the graph?
When the excluded value can simplify / reduce to 1. Removable discontinuity.
How do we find the y value?
Plug into simplified equation.
What was what were our points of discontinuity?
0 and 1.
Which one was removable?
1. 0.
0. We reduced there. Simplified that x out. So 0. Did we plug in 0 here to get 9? When we were trying to find the intercept, we plugged in 0. Realized 0 was an excluded value. Therefore, there is no intercept. There's a hole there. So what was the coordinate point of our hole? 0.0.
Okay.
Parentheses.
If you completely didn't want to use that step and you were like, okay, I'm just gonna back up, start from the beginning. I know that there's a hole at 0 because I removed that x, so I'm gonna plug in 0 into my simplified equation, and that will give me that. Good? Any questions? Good. We are finally going to put this all together. We are not going to need a graphing calculator because we know how to do everything in order to graph this.
So yeah, on my lab. Like on the test.
Great question. Summers. No graphing calculator in the test, right?
No graphing calculator on the internet.
That's what I've been using.
It's easier to do it. I'm not kidding. If you guys really get it down, it's actually easier to do it by hand. Because 9 times out of 10, you guys forget to put in the parentheses on the numerator or denominator before I check it. So I will have scientific calculators available for test day. But this is my only test the whole year that you cannot use your graphic calculator on.
Is it because you can find out the answer really easy?
And we want you to know how to do it.
Okay. So we're gonna put this all together, and you guys have all the tools you need to graph back in here. Back here, guys.
I would start getting
Oh, I am good at this. It's okay.
What's so bad?
Actually,
That's good. What's your family be like?
All right, let's go.
You let them see that.
I
I
can.
graph rational functions.
With a positive attitude.
With a positive attitude.
You are.
Getting what you're trying to do.
Yeah.
Oh my gosh, Donnie, I need to.
What are you supposed to do?
That is on you for not knowing what it is.
Anything.
Can you give that back? He needs to write his notes.
Thank you so much.
We'll go back later. Yeah.
Go ahead.
Yes. 0.
I already said that.
Are they vertical asymptotes or whole? Is that 0 vertical asymptote or whole? Not
Oh.
No, that was wrong. It's not.
Huh? Okay, so it's a discontinuity because it's divided by 0.
But it's not, I don't think it's a removable.
It's non-removable.
Oh my gosh, guys, I missed this one. Hold on.
Yay.
I used my vocabulary.
Beautiful vocabulary.
Can we simplify?
No, it can't.
No, you
Because it's
can't.
addition and not multiplication.
Amen.
Wait, that's subtraction.
Okay.
That is what I'm saying. I mean, yeah, exactly. The idea was
You
right
added
though.
by a negative.
Yes, thank you.
You
So
subtract
is this
one.
an asymptote or a whole?
Oh. And asymptote.
Asymptote. Holes are removable. Holes are when you simplify. We did not simplify, we cannot simplify, therefore this is a. Everyone say it.
Asymptote.
Asymptote.
What kind of asymptote?
A vertical asymptote.
Vertical asymptote. This is a vertical asymptote.
Article.
At,
Like the red rubber.
what is the equation of that vertical asymptote?
X equals
Someone over here said it. X equals 0. What is the horizontal asymptote? Or otherwise known as the end behavioral.
Y equals.
Not yes. No, I didn't hear it. I heard you.
Steven, but me, I was with it.
I didn't hear it. What?
It's not 1, it's X equals, Y equals 1.
You got it wrong.
Don't you tell me.
Now
That was what?
Right.
Wait, I don't want to write it down.
Don't write it down.
Okay. I don't like erasing.
Okay, because it's not x equals 1, it's
Y equals 1.
y equals
Oh,
1.
whoa.
Here's your degree. Are they the same degree?
Yes.
Wait, there's lots of extra talking. Come up here. Focus. The degrees are the same. Yes. What are the leading coefficients?
It's like a
Positive 1 over positive 1. The negative 1 is the end. This is 1 over 1. Therefore, y equals 1.
Yeah. Girl, bam.
Okay, good question. Can your end behavioral / horizontal asymptotes be crossed? Can you cross a horizontal asymptote on your graph?
Which way is horizontal?
Honey, if it's an end behavioral asymptote, can you cross it? Does it matter if we cross it? No. It does not matter. That was something we learned on whatever day we started the horizontal asymptotes. They only have to do with the end behaviors. What it's doing at the end?
It's going to infinity. And beyond.
The mouth wasn't even open.
We just asked her what her last name is.
This is true for
Okay, what are you saying?
Yeah, let's. Oh, thank you. Can horizontal or end behavioral asymptotes be crossed?
No. Yes.
Yes.
Wait.
why.
Yeah,
why?
Clearly none of us understand.
Is there any way you can move your paper down? Sorry.
What is it called? End behavior. End behavior. It doesn't matter what's happening in the middle of the graph, it's the ends. horizontal asymptote has to do with what's happening at the ends, that's what. Yes.
Does it have anything to do with maybe where the vertical asymptote zero is found?
Can you help me?
Well, I'm trying to be a student.
I know,
Student.
it's good.
Oh, wait, John got it.
Is it if you have two vertical asymptotes, you can cross the horizontal asymptote in the middle of them?
Yes. Have you guys seen those ones where there's two and there's like a weird thing, like I almost said slithering line. Maybe it looks like a snake right in the middle. But hey, when we find vertical, it's a divide by zero error, right? A math error. When we find horizontal, is it a divide by zero error? No, because it's end behavior, like what Hooper said. So it doesn't matter that that one crosses the horizontal in the middle of the graph between the two vertical, because at the ends it approaches it. And it can cross it in the middle because it's not a divide by zero error. So it's a combination of those two things. Does that make sense?
Because why can't we cross the line if it's a vertical asymptote? It's where it can't go, it's the excluded value. But a horizontal asymptote isn't found by the excluded values, it's found by the degrees of it's just the end behavior. Sorry, I didn't finish that, it's found by matching the degrees of the numerator and the denominator. There's no error happening, so it means you can still have that number, it's just that your ends are gonna look a certain way.
So it doesn't even matter.
So it doesn't matter, exactly, it matters at the ends. Good, those are all good questions. What did the x and y intercept? Okay, what were the x-intercepts then? You find it by
Setting it to 0, so it's 1.
so 1, 0. What are our y-intercepts?
There. Wait, that's wrong.
No, we are looking at the x minus 1 over x equation. It has a -1. So we plug in 0 for the x's, right? Y equals 0 minus 1. Oh, you're right. Sorry, you're right. There is none. Sorry.
Wait, why is there more? Oh my
0
gosh, that
divided
makes
by
lots
0
of sense.
So hi, yay! As you know, the x goes towards infinity and what do their y values approach? Or what do they get really close to? What do their end behaviors gonna look like? Hint. Horizontal asymptote.
Flamingo. Wait, that's
It's like Egyptian.
Flamingo.
One. Okay. That's also 1, right? That's what our end behaviors mean. Now, using the same equation, I want you guys to note. Yeah, I'm gonna do that. What eyes?
Yeah, like,
Oh,
why?
eyes.
Why don't they use it? Those get too confusing.
No, look at that. Okay, do you need more time or am I good to move on?
Keep going. More coffee. I don't even know.
Is this the same equation that we used before?
Yeah.
This is your list for how to graph a rational function. So if you guys want to write somewhere this list, or just take note of it, circle it, this is how you graph a rational function. The first thing you want to do is find your horizontal asymptotes. What were the horizontal asymptotes of this graph? Y equals 1. So we're going to go straight from there. Go to our graph and we're going to draw a vertical horizontal asymptote at y equals 1. And then you factor both the numerator and denominator. And simplify. It's already simplified, right?
Yeah.
So is this a vertical or a whole? What did we find? Vertical asymptote, and it was at
1, 0.
x equals 0. So we're going to draw a vertical asymptote at x equals 0. That is right on the y line. Why? Okay. What are x-intercepts?
1.
How do I write that as a coordinate point? 1, comma 0. So here's the point at over 1, stay at 0.
It's your second.
Okay. Are there any y-intercepts?
No.
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 Do they have to be dotted lines?
Yes, those are our asymptotes, so they're not part of the graph, they're just the graph shapes.
Oh, gotcha.
Now I want us to make a table. And we need to find a few more lines to figure out where this is going, okay? A few more dots. We're going to want to find a dot over here. So we're going to say -8, -4, -1. And we already see where 1 is. So let's do 4. I am going from left to right, adding numbers in there. Making sure not to choose excluded values.
The excluded value is 0 though.
Correct. So I just didn't put 0 in my table.
What happened if you did?
top one X and the other F of that?
Yeah, I started writing F, and then I was like, no.
So it's the F of X third Y.
F of X is the same as Y.
Okay.
Okay, what is -8? Plug that into the equation. What do you get? -9 over -8, which is positive 9 over 8, right?
Wait, where did you get?
We plug in right here.
Which is
Y equals -8 minus 1 over -8. -9 over -8 equals
Oh,
positive 9
because they're
over 8.
both negatives. Silly mistakes.
That's like a little more than 1, right? So right here would be like right there. Because it goes over -8 up 9/8. Good? What about -4?
5/4.
So is 5/4 bigger than or less than 9/8? Bigger than. So we're gonna go to -4, go slightly above version. So I can already tell that this is probably gonna be going this way, right? I got 5/4 here. Okay, -1. Now is it quiet because you guys are understanding, following along, or totally lost? We good?
Yeah, no.
Any questions?
We're good.
So that was 2. What about 4?
Oh, 3/4.
8.
7.
Okay, is 3/4 bigger than 7/8?
No. No. Yes. No. Maybe.
No.
No.
Right?
Right. That looks like it's half.
Oh, negative. Negative. No, positive.
Oh,
Sorry.
3/4 is the same as 6/8.
yes.
So
Yeah,
7/8
yeah,
is bigger than.
So 7 is bigger, yeah.
Okay, were there any other x-intercepts? We just had one x-intercept, correct? So is this line gonna go down or up? Up. So it's gonna go like this. And then this one just crosses the x-intercept, so that one's gonna go like this. See how it crosses right here? So I know I'm not gonna go that way. I'm gonna go down. Yeah.
Doesn't the fractions like follow like the rise over?
No, that is the slope. If it was in the form y equals mx plus b,
It's like how do you put in the fractions like into the like?
it's just, yes. Are you answering the question? Good.
So the way I think of it is like in each little box, you're like cutting it up, and then so like for the 3/4, like if you cut the little box before, and then you fill in the big boxes. That's what it's.
Yeah. Yeah, so a fraction is a number, right? Is a fraction a number?
That's how
So is a number factor in your graph?
ever since.
So, we need this is for you. We good now? Okay, it's just a point. It's like a decimal point or a fraction. It's just a number. It's a point on the graph. So you went over -8 up 3/4. So we didn't go up 3/4. We went up 3/4 of the lines. Okay. Yeah. Okay, so this one, I could see that these are getting smaller and going towards that asymptote. This one, since it's going up, and also because it's not going to cross that x-axis, and it was going to go up. It can't cross that line, so it was going to go up. This one was going like this way up, or this way down, until it crossed, so it was going to just keep going down. We good? Any questions on how I got my up and down behaviors? Okay. I want you guys to practice this one together in your table groups, okay? So make sure you're in your table groups. And looky, it's already factored.
What?
Better that it's already factored, right?
Yeah. Yeah. Oh, yeah.
Just wish these would say like, yeah, but okay, so we can all use this. That is my little cheat sheet that I gave during, what was it after school? How many x's are there? Two on top, two on bottom, so the degree on the top is 2. The red one was in this. 6 over 1. Wait, see, because this is a coefficient. So these are the same. Okay, I see that. I was just confused.
No.
added it. Like that.
You said, oh, wait, you said y equals y. Oh, wait. Wait, you said x is 0. Yeah. Then you get to y. Y is 0. So, alright, so 0 minus 6, 0. So negative 6 times 5. So,
The top would just be 6, right?
There's nothing. Yeah.
45. You set all x's and you divide
Yeah, and then you're gonna set like that, and you 6 doesn't equal 0, so there's nothing you can do. Yeah, and then those
I don't think the what?
Oh, you don't need to distribute that. Oh, what do you do?
You gave the. Oh, yeah.
that is not what I got, but I'm pretty sure about
Wait, so that's always keep going, yeah. Wait, no, vertical is the denominator. Vertical is the one more, like excluded values, right? Excluded values come from the denominator. But how do you find the vertical Yes, oh, what you're saying is change it to 0? No, you set it equal to 0 and
yeah, but then
vertical asymptotes are excluded values that can't count. No, solve inside the parentheses and then just multiply. Okay. Like we're gonna figure it out.
yeah, but 6 on the outlet.
You do. It does matter.
Okay, so it comes back in later, so then my answer would be.
What? All
And that simplifies down. I don't
You multiply the 6.
What's 5 on the 2? Okay. That's our baseline.
So when you want to get the.
What is on the bottom? Oh, sorry. They're both negative.
She caught up weeks ago. I just.
One.
Did they give you a ticket?
Huh?
Did they give you a ticket?
Yeah, I definitely did that while my dog was
Like all the things, like when you wrote them down, I didn't check. Yeah, for sure. I want to say something. It's the
Sorry, I like messed up. Here, no, what happened is
I have mentioned.
all over.
Okay, so.
No, I just took no work.
yeah, like you set all the X's and like zero and you saw.
It's like, what if you like 6 times 0 minus 6?
Yeah,
Like
right.
0 plus 5. Over 0 minus 8 times 0. Like that.
So it's just the X's all become zero. So just imagine all the X's.
So like it would be like,
And it's, yeah, it's a
6 minus 6, or 6 times negative 6 times 5.
Wait, that's so right. Because before I got 3 halves, I do.
Yeah, it doesn't.
Zero, that's where you set up the 0 to
I don't even know what. -5.6.
So the vertical asymptote means
basically,
this way,
it's basically you're doing
and
the
it's
number
telling
beside
you
the
what?
for the vertical, for like the other attitudes, you're just saying any number beside the
Because you set the numerator. Oh.
I'm actually confused.
It's the other X.
What date?
I don't think that's right. It is, I'm telling you, Drake, it's right.
So we multiply across the top
I
and
told
bottom,
you, bro.
and then you see.
Well, we actually figured it out. That's what the few more points is for.
What do I do with this?
Yeah. Look at it. No, I don't like the graph.
Those are like, can't be. So it's never gonna cross those lines. So we don't want to, the way I grab it, it's like this whole line, that means you're never gonna touch it. You're staying here. Never gonna touch it.
Oh my God.
like the 6 with the 7 numerals, or you just be
Okay.
Okay, so let's make sure.
It actually makes sense.
Yeah.
Isn't Sophie Dawson?
Right there.
You just walk in close to the chair.
No.
I think I'll do mine.
Oh,
Maybe I'm gonna dress Grace got the same chair.
she's a better.
Wait, so the exit, yeah, exit is what? That's where it intersects.
You can take rest, but-
So it would be like this. 6 and -5.
What?
You didn't put them as points, you just put them as. They are. So in order to have them correct.
Did you say you got 130 on the bottom?
You can divide.
That's just the.
No, 30. Okay, I don't know why I got 32.
Yeah, well, because you only have this for I know, so for a second, I was like, 30. Because like, because you can try it.
Yeah, wait, it's
Might be
just-
just
I
Negative 6.
So
now, I changed all my.
Do you want to write?
Oh.
You do negative 6. Find your negative 2 and out like this time. This 7.
Oh, good.
That's kind of soon. Oh, next week we have one more lesson and then review and then.
I'm missing out one more lesson.
Wait.
You are? Yeah, so I have to drive over it to finish some. You'll find out if I need to fix my ACL. I'm missing out.
Wait, how long have you been doing this? I thought it was today, maybe today was just like more drill of. I thought we're doing the same thing like.
Miss Summers, what time
Yeah,
is
so
it?
last time we just.
2:04.
Is there any way at 2:10 to go make an announcement?
I hate German.
Okay, 37.
Yeah, wait, is Marcus a people in there?
I'll be out and see the model.
No, it's the right.
I can
I'm
do
gonna
it.
take care of
I'm
it.
careful on my good side.
I had that.
I can't double on my good side. I can do that. Okay, what are we doing this? We're just having fun or whatever.
Really?
No, I can do it. I can do it single turn.
We're ready to go on the floor.
I just go to my right and I just show it's like negative. On the other side of it, everything is no, I'm talking.
Okay, next one,
We all have like 0.
So they're like this.
I need to learn how to do that. Oh my God.
Negative 1. I don't get that. So they're okay. Yeah, I guess that. Then what did you get?
I don't know.
By the way, I
Still can't believe it.
I've just hit it so many times. Like, it is a fraction.
What volume is that?
That's kind of weird.
My shoulder hurts so bad.
36 over. Let's see if that's similar.
I can't figure this out. I can't figure it out. I also can't use left hand. It takes me forever to realize what
About 5.
I'm a lefty, so it's easier, and we start with the right, so I feel like I'm good on both sides. It's like, I can't do it. I can't do
Double
single.
sides. I missed out on the one day that we were
Yeah, you say like, I just get out.
Like, it was very much like, I didn't want to sum it better now.
I love the abstract learning.
It's so more. Okay, it's gonna be.
Don't look at that.
Oh my gosh.
That one wasn't it negative
Y
4 and
intercept.
on?
We needed a number. Y
Oh my goodness.
Zero is Y intercept.
Yeah, but then there's an x-intercept at 6 and -5. I'm gonna make it solid, so we know that that one was wrong. I'm gonna give you some-
Wait, how is it negative? That's my question.
What's
Is
your?
that gonna be a little
What?
Because that's what the top number is.
Well, you guys not asking me.
Oh, okay.
Zero and 45, 8.
It's 5.625.
Come down.
Okay, what were other points that you got? Or did somebody already grab this graph? Come up and grab it for me. Hassan, did you grab it? Very quick.
Megan, 37 tickets, 210.
What?
37 tickets. Yeah, you offered 37 tickets. She won't let you do announcements.
Yep, 37.
This isn't an
It's
announcement.
210.
I'm showing my tickets for go. Man, that one's
I gotta
right over
go.
there, guys. You have no idea what you're talking about.
Yeah, it's all right. But Drake will tell you this for $37.
Yeah. How did I get it? I just kept mine last term. Were they-
Are you allowed to do that?
Can you do that?
I don't know if you can call me because
Should have sold them.
Oh, yeah, no, I did. I put it in, I gave it.
I don't do
And then he bought 11 from another $15. So he owes me $15. Max, you're only $15.
He told us he's, 14 about that.
14 over
I lose my tickets. What did you do when Max came in with a hip score?
So he didn't have to.
That's about 4.
Yeah. Why?
Very expensive. Thank you. Is it possible for me to just figure out what these lines are without having a table?
No.
No, I didn't need a table here. Okay, this one you'd want, plug in a 10,
And negative 10.
10 and negative 10, what did you get?
4 and 4. And like some, I think it was like, I don't know, some number.
Okay,
I didn't get the 10 on
tell me
that.
over here. So it's like this, yeah?
Yeah.
Okay, and then Preston had points that he had plotted inside of these lines. So that's how he figured out what this one looks like. He crossed the y-intercept there, and the x-intercept there, and then he found other points outside of them to know that it's connected to make it look like that, okay? And then putting in the 10, it's 4.4. I don't think it was 4.4. It had to have been above 6.
It's too like 12.
It's like 12.
No, like it's 212.
212 divided by something.
It's 212, like the time.
No, right, okay. Okay, it probably looks something like that.
I didn't even realize it was. I didn't yeah, I didn't draw that.
Yes, because if you plug in 10, that's gonna help us know if it's gonna be above that line or below that line. Yes.
Is that y-intercept correct? Because y-intercept I got was completely different.
What did you go?
I got 5 over 4.
Okay.
Can you tell her how to get it?
Huh? X -6, 5, because they're putting in 0 for all of those, right? Over -8 times 4. Yes.
Yeah, that's essentially what I did.
6 times -6 times 5.
Hey Leslie, attention all juniors. Today is our last variable practice for this variable that is going to be held on Monday during hammer time. We hope to see you guys there. Meet in the dance hall room at 2:20. Thank you guys.
45 over 8. You got 5 over 4.
I'm not sure how I got there. Somebody Raven told me I was wrong. I think it's right.
Okay, you guys, you can do this, what I just did here, on a scientific calculator. So, we can be okay that we're going to use scientific calculators.
Have your weekend, be safe if you're going out for Halloween.
Oh, yeah.
Keep forgetting it's
I
Halloween.
forgot Halloween.
Can we have Alyssa Roberts and Jackson Melville to the front office? Alyssa Roberts and Jackson Melville to the front office.